when I was reviewing some of the submitted sessions for our user group, some main themes emerged. Supporting diverse workloads is a challenge that everybody's facing these days, and just how do you get your arms around the sheer volume of data that folks are having to address these days. And these are the things that DDN is also obsessing about and working on making all of that much easier for you. And we've got some interesting updates to talk to you about today. And so I highly recommend sticking around for Sven's session towards the end. You get a preview of a project that we've been working on for a number of years. Without taking up any more time, since we started a bit late, I want to turn it over to Alec.
Well, thank you very much for joining us today. Finally, I guess the world is going back to normal and we can all get together in all of these beautiful places with the great rain and the cold weather and so on. So we have a very exciting agenda for you today. We'll be speaking mostly about new technologies that are applicable to the use cases that you all encounter in high-performance computing, in AI, in the acceleration of workflows, and getting better insight from the massive amounts of data that we have to process in various places. And DDN, of course, has been focused on enabling and making all of these things a reality. So let me see if I'm going in the right way. So very broadly, as you well know, DDN as a company, we've been doing this for several decades now. Our focus has always been solving very, very complex problems which involve data and involve data at scale. So initially we started out in high performance computing, government labs, and academia, research facilities, and so on. And gradually, as the world started understanding that data could be an enabler, irrespective of the industry or the market segment or the use case that you were in, our addressable market expanded. The systems we started to deploy trickled outside of academia and government labs into industry. And so the business really gave us an ability to develop the kinds of capabilities that in the end benefited and favored what is going on in our industry in high performance computing. So what is it that DDN does? I mean, I think we accelerate data and we accelerate insight into data. We do it for large-scale implementations, but we also do it for entry-level, department-level types of use cases. And that, as the world has evolved and as we've seen really data being prevalent not just in the data center, but going one way into the edge with the collection of data through sensors, through cameras, through various types of devices, then the processing of it, the storage of it, the analysis of it taking place in the data center, and that cloud being an essential component of it. That is really the problem that DDN is solving at scale. It is an at-scale requirement that goes from small to medium to large to very large, but it ties all the pieces together in order to provide efficiency. Efficiency in management of data, efficiency in the storage and processing of data, power, which has increasingly become a requirement for organizations dealing with the problem of power as we've shifted from a hard drive-based environment into one which has SSDs and hard drives, GPUs, as well as processors, networks. So solving the problems of power in conjunction with data is one of the areas we've been focusing on. And so from a product standpoint, what is it that we do? Clearly, we focus on data at scale. So that is really the enablement of AI and HPC. So it's developing storage solutions with intelligent software supported by highly scalable amounts of media, again, drives and SSDs, and we'll get into a lot more details on that. But also two more attributes. One, enterprise types of capabilities, not because we necessarily want to provide enterprise solutions, but simply because developing those kinds of capabilities give resiliency, reliability, ease of management, ease of support, ease of upgrades that we find everybody now requires, and then permeating that into the cloud. How do you implement a cohesive IT framework, IT strategy, which ties all the elements of it, not just in the data center, but a distributed type of environment with lots of flexibility in it that goes from the edge to the data center to the cloud. And so that is the focus of the company. DDN continues to be very much of an engineering organization. 60% of the people at DDN are engineers. So out of the 1,000 or so people in the company distributed throughout the world, 60% are engineers. So we're still a very, very technical company investing very heavily into research and development and bringing the right types of solutions and technologies into the market. We are a technical company. So in terms of, what is it that our solutions look like? Our investments are primarily in software, but software as an enabler for the underlying media. Because fundamentally, data, even in a distributed fashion, needs to be stored and processed somewhere. And so you need massive amounts of it if you're solving problems at scale. So developing technologies and solutions which address the various types of areas where data needs to reside and be processed, but taking an end-to-end approach to it is what DDN solves. And we'll be talking in DDN's product portfolio, what that really means, what are the products that we're bringing to market, what are the capabilities and features that we'll be bringing to market in 2023 and beyond. But parallel file systems, obviously, because that's the best way for these types of workflows and use cases in HPC and AI to solve the efficiency challenges, the power requirement challenges, the scale challenges, but also all of the other aspects of it. Containerized environments are becoming more and more important. So the ability to do that efficiently, home directory, the mix of data and metadata, and solving the efficiency challenge, not just for the data, but for all the pieces of it. And then clearly the backup and archive, and doing that very efficiently, intelligent tiering of data and archive types of requirements. So that's kind of, I think, increasingly the picture that we see. We see this in AI types of workflows, but we see it in a lot of use cases which are now being deployed at very massive scale. I mean, this could be an autonomous driving requirement. It could be a surveillance requirement where you have sensor data, which is at the edge, highly distributed, where you're continuously collecting 24/7, and that needs to make it somehow somewhere into the data center. And many of the current technologies that have been deployed or have been developed don't know how to do this with high levels of efficiency. So what ends up happening is you either end up having the system hiccup, or you end up with a very, very cost-prohibitive implementation where it starts out okay because you're starting at a smaller scale, but then as you ramp it, then the cost just skyrockets, and then hiccups start to come in, efficiency drops, and so it becomes unmanageable. And then the other piece of it is in the data center. Once you bring it into the data center, you ingest it, you process it, and so on, you gain insight from it, then it's moving it into the cloud. And again, the issue of the cloud is, getting it into the cloud is fantastic. I mean, it's like Hotel California, you can get it in, it's great, it's very inexpensive, but then getting it out, it's quite challenging. So there's a cost issue, there's just a latency issue, and so 4 or 5 years ago, we started looking at the problem not just in terms of, hey, there's a data center and we're going to optimize within the data center, and we're going to optimize end-to-end from the applications into the processing of it, CPU, GPU, to the network, to the underlying medium, but solving that problem clearly, but also then connecting it from the edge on the one hand and then into the cloud on the other hand.
Thank you, Alex. Actually, I'm showing you his face first, but Mark Hamilton will be with us as one of our speakers this afternoon. And like he said, basically, I mean, his quote from ISC in June in Europe was the differentiate. It's his story, and I think I'm not going to break. I should actually let him do it. But I mean, the point was they went to DDN. We were not like their initial choice, right? And the roadmap, and I don't know if he's going to say it or not, but I'm just going to say it now. And it took him like probably about a year or two to figure out that DDN was the only solution for the large system. And one of the major elements was checkpointing, right? Is that at large scale, systems are becoming larger and larger, and you need to be able to know that everything is in check, and that the levels of balancing of the system, both in writes and reads, and writes in the case of checkpointing, basically led him to DDN, and then obviously they figured out all the other elements. And since then, over the past 2-3 years, I mean, our relationship with NVIDIA has blossomed. I mean, we obviously work with the other vendors, but NVIDIA has really been, revenue generation. I think we drive about 4,000 to 5,000 DGX-like machine today, which is in less than 2 years. So picture the amount of power and amount of computing that we basically stand data behind. I think about 90-95% of this, what we call superpod, that means more than 20 DGX are running with DDN at this stage. And so this means that obviously, and we're finding that the work we've done with NVIDIA is really very helpful, right? So we deploy within NVIDIA, we sell them system, and so there's a very close tie-in between our engineering team and application teams with their teams. And so there's really connection with the Mellanox, be it either IB or Ethernet, with the GPUs, with and in the future with some of their next generation technologies as well. But I mean, if you look at it, it's very diverse worldwide. We also have someone from KLA, later today that will speak. That's an application for semiconductor checking equipment. But UF, CDAC in India, Argonne National Lab, Bosch for video surveillance in Germany, Recursion, which is for drug discovery and acceleration for pharmaceuticals, Docomo Telco, Total in basically in oil and gas. So as you can see, it's very diverse. WASP is for natural language processing. So a lot of applications where we fielded, all these are in production, and this is really past 2 years. So as far as just a high level as to, here we go. Past couple of years, right? So if you look at it in 2020, we delivered about 1.5 exabyte of capacity globally. In 21, 2 exabyte, and 22, we're on the range between 2.5 and 3 exabytes, right? So the capacity is growing, the bandwidth obviously exploding. And then what we're seeing, however, is that the flash portion of this grew 4x between 20 and 22. So we're seeing that the portion, obviously, of flash is growing, but it's still predominantly HDDs when you look at the big sites. Thank you. And now I would like to welcome the next speaker.